we interrupt our program to bring you this important message.
You're here tonight to learn about our Juno mission to Jupiter. Juno launched in August of 2011 and will arrive at Jupiter on July 4th, right? July 4th, Independence Day, 2016. So tonight's guest is the project scientist for the Juno mission. He's Steve Levin. He received his PhD in physics from the University of California, Berkeley in 1987. Where he then worked as a postdoctoral researcher and research physicist until 1990, which is when he came to JPL. His research interests have included measurements of the cosmic microwave background radiation, the search for extraterrestrial intelligence, measurements of magnetic fields in star-forming regions, and modeling of the inner Jovian radiation belts. He has done radio astronomy with instruments on mountaintops, at the South Pole, on large radio telescopes, on high altitude bands.
Terrific. Thank you. Okay, so after that introduction, I feel like it must be important or something. I'm going to tell you about Juno, which is on its way to Jupiter. And as you just heard, gets there on the 4th of July. Cross your fingers, I'm sure everything will work great.
Today is the 4th of July, and you will once again be fighting for our freedom. Not from tyranny, oppression, or persecution, but from annihilation. We're fighting for our right to live, to exist. Today, we celebrate our Independence Day.
All stations on Juno Accord, we have the tone for burn cutoff on Delta B. Ground move Juno, welcome to Jupiter.
From 500 million miles away, a signal that told Mission Control that their £800 million spacecraft was safe.
$100 billion!
Oh, gentlemen, silence! Now, Mr. Evil.
Dr. Evil. I didn't spend 6 years in evil medical school to be called Mr. Thank you very much.
It is the policy of the United Nations not to negotiate with terrorists.
Really? So long.
A kleptomaniac.
In a matter of hours, a meteor will crash into Earth, causing a global flood. That is, of course, unless you pay me 1 billion, gajillion, fifillion, shabadoodle.
All right, well, by now you should be asking yourself, why are we doing this? And the answer is that
if they all respond to stimulation of the senses, then maybe we can distract them. They can't have been able to handle the senses yet. If we can confuse them enough.
It seems reasonable.
All right. It may be our only chance. Look for any way to stimulate the senses.
we see a giant aurora in Jupiter's upper atmosphere, the north and south poles, northern and southern lights. So you see these northern and southern lights that are from electrons streaming down the magnetic field lines, ions, crashing into the upper atmosphere and glowing when it hits the atmosphere. That's the northern lights or the southern lights. All right. Well, I promised to rush through and get to where we could answer questions, and now I'm going to spend about eight hours on this slide. But that's because it covers more or less the whole mission.
I was curious. What is it?
We have a whole suite of instruments on board the spacecraft whose job it is to measure the particles that hit the spacecraft, measure the plasma waves traveling through the magnetic field in the plasma in the magnetosphere, an ultraviolet spectrometer that'll take pictures of those aurora, an infrared camera to take pictures of the aurora and measure the spectra that'll also help us with the atmosphere. And then finally we have a visible camera on board, which actually it'll do some good science, but it's not there for science. There's the spacecraft with the different instruments on it. These great big things are the solar panels. The size of the container part of the truck would just about fit on one of those solar arrays, on one of those arms. That's the size of it. Another way to look at it is on a professional basketball court, you could just barely fit the spacecraft on the court. Okay, so that's the size. And then our longest wavelength, our lowest frequency channel, penetrates down to some of the information it's getting coming from a pressure of 1,000 bars. If you had radio eyes, this is what Jupiter would look like from the Earth. It's called Juno Cam, and it will take great pictures to make the map that's used for people to look at the map and pick out spots and say, take a picture of this. This looks interesting. Take a picture of that. And then there'll be a discussion section, and we will, the scientists, if a scientist wants us to take a picture of some particular object, go to the website, put it in, compete with Mrs. Field's third grade class to make a good case for it. And then there'll be a system of voting where the public can vote on which pictures should be taken. And we'll take that into account in choosing the pictures. So we hope to have a good scientific discussion about it, probably mixed in with comments like, that looks pretty, which is okay. We have a limited number of pictures we can take, and so we want to choose the best ones, and this is how scientists would normally do it. Beckerist asks, if it only takes a couple hours from pole to pole, how fast is Juno going? So the short answer is, I don't know. The longer answer, but of course Jupiter's moving, and the Earth is moving, and the Sun is moving, and the galaxy is moving. So take your pick. For a while there we were looking at trying to compare the speed of Juno with the launch pad on the Earth from which it launched. So the Earth's spinning and moving, and Juno's moving, and Jupiter's moving, and all of that, because you got a decent case that Juno's the fastest thing ever built by people. So the entire output of the Juno spacecraft from beginning to end probably fits on my laptop, or pretty close to it anyway. We're sending it all the way from Jupiter, so you can't send it really fast. Having said all of that, the most important thing we want to measure is probably the global water abundance on Jupiter, and that's one number, a few bytes.
If someone was on a good spaceship, how close could they get to Jupiter? without
if a human being was trying to survive in Jupiter, is that what you're asking?
Yeah.
Now I really don't know. I would say it's pretty hard to send a person to Jupiter because they want to ride home, and it's hard. It's hard to bring a huge rocket to Jupiter to come back. That's why we send robots, because they don't have to come home. But if you ignore all that and say how well could you survive, I don't know the answer. My guess, and it's purely a guess, would be not very long. This person doesn't have their name on it, but it says, when Juno is decommissioned and sent into Jupiter, what studies will be done during descent? So they're mentioning something that I didn't mention, but you can find on the website, which is the plan at the end of the mission is to crash the spacecraft into Jupiter.
After orbiting Jupiter for over a year, the Juno craft will dive deep into the atmosphere and burn up. But the mission will never truly end.
The plan at the end of the mission is to crash the spacecraft into Jupiter. And that's to protect Europa, because Europa has a liquid water ocean. We'd like to look for life on Europa. You'd really hate to spend lots of money in 50 years and get to Europa and dig down in the ice and look in the ocean and find life, and then have to say, I don't know if it's from Europa or contamination from Juno. So we have to make sure we don't do that. It means we're going to destroy the spacecraft by crashing it into Jupiter, unless we can figure out a way to wriggle out of that. So this person is asking, what do we do? What studies will be done during the descent? The answer, we haven't settled on that yet, but the answer is probably not that much.
Will Juno be able to measure the, how shall I say, redometer and the interferometer around the equator?
Okay, I'm not 100% sure I know what you're asking. So, are you asking about if we'll be able to measure the radiation around the equator, the big radiation
Well,
belts,
no, I should
or
have qualified. I was talking about convection.
Oh, okay.
Around the equator.
When I look at that and look at the explanations, a lot of it boils down to, well, we know this part and we know this part and we know that part, but in the big picture, to really have a full explanation, the answer is still, I don't know. It's a hard problem. For the microwave receiver, I suspect that the biggest thing we need to worry about is that Jupiter will surprise us somehow in how the atmosphere behaves and how its temperature dependence behaves. And we'll get the measurement, but then we'll have to puzzle it out to figure out what it means.
How far is Juno far to Jupiter?
Ah, okay. So...
Oh, in miles, please.
All right, let's see. So, I don't, Earth and Jupiter both move, and I don't happen to know exactly where they are right at this moment, but roughly speaking, it's about 500 million miles to Jupiter. And I don't know exactly, because the spacecraft is moving and I haven't looked it up lately.
I was wondering, so if there was life on Europa, could that have had any difficulties associated with the intense magnetosphere on Jupiter?
Right, so if there's life on Europa, would the radiation belts destroy it, right?
Mm-hmm.
And maybe.
Squeeze? Oh, no, you did.
Water, life where, maybe it's not a person, but it's, or a mouse, but it's a creature that you would look at and would recognize as that's alive, and it looks similar to the kind of life we know. On Jupiter, I'd say the chances of that are vanishingly small. And that's because the temperatures are crazy, right? It's cold at the upper atmosphere, but it gets hot pretty darn quick, and you get, there's nothing to stand on, so you fall in a little bit into Jupiter, and now you're at temperatures that are 1,000 degrees and pressures that are, thousands of times the pressure here on the Earth. Hard to picture life surviving in that. Water, there's water vapor, maybe there's water droplets if you find yourself at just the right altitude. There should be clouds and stuff, but it's not like here where there's oceans and things like that. Storms, thousands of mile-an-hour winds, all of the stuff makes it hard for me to picture life, like a puppy living on Jupiter. People would puzzle over and ultimately conclude, yeah, that's alive. Sure. I think that's plausible. Nobody's ever seen anything remotely like that, but we don't know that much about Jupiter. A comet hit Jupiter some years ago that was really interesting, and the whole world studied it. And it led to the question of, hey, how many times has a comet hit Jupiter and nobody noticed? And we didn't really have a solid answer for that. There's more people looking now because that was such an interesting thing. If the Earth got hit by something asteroid-sized, say 1 billion years ago, there'd be a huge change in what you see here on the Earth. And if you tried to figure out what happened before it got hit, that would be difficult. Now, we don't think it got hit by an asteroid-sized object. Well, maybe a small one.